Hi, Assalamualaikum. My name is Ahmad Rizal Hakimi bin Norman Rizal. My metric number is CD230316. And today, I would like to present about my project, which is inspection and maintenance practices of fire and gas detection systems in industrial facilities. For my case study, I do it on my yard, which is Nastec Solution Workshop Audit. So, before diving into the technical details, a mandatory safety briefing must be established. During the site walkthrough, full industrial PPE, such as including safety helmets, high visibility vests, safety glasses, and also steel-toed boots, was worn at all times. Furthermore, strict safety protocols were followed on the shop floor, keeping a safe distance from heavy crane lifting zone and also high pressure hydraulic testing rigs. Next, for introduction and problem statement, an automated fire and gas or FNG system acts as a critical 24/7 safety barrier to protect personnel and heavy assets. Nastec Solution is a newly established mechanical service workshop that handles overhauling and pressure testing heavy crane blocks and also high pressure hydraulic components. The core problem statement is that because it is a new startup facility, there are currently zero active electronic smoke, flame, or gas sensor on the premise. This project analyzed the baseline reliability of their current manual safety items to provide a realistic roadmap for automated upgrades. In a standard industrial plant setting, an FNG system uses three primary sensor types. First, a gas detector to locate toxic or flammable vapor leaks. Optical flame detectors spot radiant energy from open fires. And smoke detectors catch early electrical faults in enclosed rooms. Ideally, these sensors communicate directly with the central control panel to trigger audible alarm and activate emergency shutdown or ESD loops to instantly isolate hazardous fuel and power lines. The scope of this project is strictly limited to the physical workshop flow and immediate evacuation path of Nastec solution. The primary methodology was a physical walkthrough audit using a standardized technical checklist. Because no active electronic equipment is installed on site, typical diagnostic instrument tests like bump tests or gas calibrations were substituted with manual visual and physical integrity checks of the existing safety tools. For inspection and maintenance activities, the actual inspection task involves surveying the primary crane overhaul base, the hydraulic test bench zone, and the administrative office. Maintenance tracking focus on examining the physical stability of wall mounts, verifying that extinguisher safety pins are intact, and logging pressure indicators. Because there are no historical system automation logs on record, the facility currently relies on daily visual sweeps conducted by the technician before morning operation begin. Next, for our technical result and finding, the complete fields finding are summarized here in the table given. The visual log confirms that Nastec solution is equipped with exactly two units of wall-mounted portable fire extinguisher and illuminated exit sign and also two-way exit door. However, the most critical finding remains the structural zero under electronic sensor assets. Next, for system performance analysis, by analyzing these results, highlight that high-risk engineering tasks such as washing components with chemical solvents or pressure testing hydraulic blocks take place without any automated monitoring. As modeled in the figure, heavy crane components stored on the floor creates massive visual blind spots. Furthermore, the lack of an electronic panel means there is no automated ESD loop to cut power during a sudden flash fire, creating a dangerous dependency on manual human tracking. For recommendation, to mitigate this risk, it is recommended that Nastec solution upgrade from a reactive framework to an automated engineering control system. As mapped out in the figure given, architecture block diagram, the immediate priority is to deploy targeted optical flame detectors facing the hydraulic bench, combustible gas detector near chemical solvent base, and smoke detectors in the office. Future phases should implement a formal fire and gas mapping study and design an active ESD power isolation loop. Lastly, in conclusion, the core project objectives has been successfully achieved, while Nasdaq Solutions' foundational passive equipment and evacuation route are well maintained. The overall fire and gas protection system is fundamentally incomplete due to zero automation. Transitioning to an active, automated electronic system is a crucial requirement to guarantee long-term workforce safety and protect valuable industrial assets. That's all from me. Thank you.